Hi, this is a short video showing the amazing capabilities of the Raspberry Pi Pico. The Pico generates VGA signals to display different patterns on a monitor with a VGA input. This is one of the many projects created by Hunter Adams, who is an instructor at Cornell University. The Pico uses PIO, which is Programmable Input Output features found in the Pico and DMA channels to interface to VGA monitors. The Pico is a powerful resource used to interface to external devices such as this VGA monitor with very little help from the Pico's ARM processors. The Pico generates two VGA control signals, Vsync and Hsync, and three data signals, red, green, and blue, or RGB. One of the ARM processors inside the Pico sets up a video buffer that can be continuously updated. The ARM processor also sets up two DMA channels to send data, the RGB data, to the PIO, which then sends the color data to the VGA monitor. In this VGA project created by Hunter Adams, we see a static pattern displayed. In this case, the video buffer does not have to be updated. So we just show one static image and it doesn't change over time. This is Hunter Adams' demo showing two objects moving across the screen and bouncing off its boundaries. The demo shows two very useful features of the Pico, the DMA channels and the Programmable Input Output, or PIO. This is a close-up of the Raspberry Pi Pico. There are 6 wires that connect the Pico to the VGA monitor. This first one to the left, this black one, is the ground signal. The next two are the control signals, Hsync and Vsync. There are 3 resistors that connect to the color signals that are shown here, these 3 resistors here. We can see the 3 wires that connect to the VGA monitor. This first one to the right is the red, the next one is the green, and then the third one is the blue. As already mentioned, the Pico is connected to the VGA monitor through these 6 wires. So let's see if we can take a look at the back of this display so that we can see how things are really connected. So wires go from the Pico over to this VGA cable through that connector. This is something that I just put together. And then that cable, that video cable, is connected to the back of the monitor. We will show what the control signals look like on a digital oscilloscope. So as mentioned, the orange and white wires are the 2 control signals, the Vsync and the Hsync, and I've got those 2 signals connected to the oscilloscope through these 2 probes. So we can see the data displayed on the scope here. So the yellow signal is the horizontal sync and the blue is the vertical sync. Links to the source code for the 2 Pico projects and a more detailed description of VGA timing are provided below.